Hello and welcome to the lesson. Today we're going to be talking about some absolute values and solving inequalities with one variable. So we have a progression of 3 different samples here. All right, so in this one right here, we're going to always remember, because we have the absolute values, we are always going to have 2 different situations, because 3 is 3 steps away from 0 and -3 is 3 steps away from 0. So before we can set up the 2 situations, we need to have absolute value, and then you need to have your symbol, your inequality symbol, and then a number. So it doesn't matter what this symbol is, as long as it's a symbol. It doesn't matter what's inside the absolute value, but you need to have absolute value, then a symbol, then a number. So 3 things. So that's what we have here. We have absolute value, then you have your symbol, and then you have a number. So that means we can set up our 2 situations. And one situation is just going to be x minus 8 greater than or equal to 3. And the second situation is going to be x minus 8. Now remember, we have to flip this sign and make this -3, because 3 and -3 are the same distance away from 0. And now we can just go ahead and solve this. Plus 8 plus 8. So x is greater than or equal to 11. And then plus 8 plus 8. So x is less than or equal to 5. All right, so now when we go ahead and graph this and put this on our number line, we have 0. Now, when we look at this from the very beginning, it's greater than or equal to. And we talk about greater than or equal to is like our compound inequalities, and our compound inequalities are going to have 2 on the same. So we either have an and, which they shade together, or an or, in which case they shade out from each other. Okay, if it's greater than or equal to, those are the ones that are going to shade out. So let's see if that's what happens to us here. So at 11, we're going to have a closed circle because we have the line underneath, greater than or equal to, and then we're going to shade greater than. So now when we do the red one, we're at 5. Again, it's a closed circle, and it says any number less than or equal to, so we're going to shade to the left. So exactly what we thought would happen. Greater than, so it's an or problem, and we shade out. All right, this guy right here is 1 step more difficult. So remember in that last one, I said you had to have absolute value, then your symbol, and then a number. And if we look at this, we have our absolute value, and then we have our symbol. But do you see right here, this -2 is between the absolute value and the symbol. And we do not want that. So we need to move that 2 before we set up our 2 cases. So I'm going to have to add 2 to both sides. So now I have the absolute value of 3x minus 9. Now this -2 and +2, these canceled out. So now we have our symbol, and 7 plus 2 is 9. Okay, now we have our symbol, our inequality, and then our number. So we can set up our 2 cases. So case 1 is exactly what this says without the absolute value. And our second case is going to be 3x minus 9. And remember, we're going to flip that sign and make it -9, because 0 is equidistant from 9 and -9. Now we just go ahead and solve this. So add 9. So 3x is greater than 18. Divide by 3. Divide by 3. So x is greater than or equal to 6. And in the red one, we're going to add 9. So we have 3x is less than or equal to, no, -9 plus 9 is 0. And then we're going to divide by 3. So x is less than or equal to, and 0 divided by 3 is 0. So now we're going to go ahead and graph that. And if we go back to the beginning, remember in a number line I always like to put 0, so let's go back to the beginning, and do we see how this symbol is greater than or equal to? That tells me this is going to be an OR problem, and I'm going to shade out from each other. So let's see if that's what happens here when we graph these two. So let's put 6 on here, and it is a closed circle because it's greater than or equal to, and because it's greater than or equal to, we go to the right. And then we have our red problem, any number less than or equal to 0, so it's closed, and less than goes to the left. So it did exactly what we thought. It's an OR compound inequality, and they shade out from each other. All right, this third problem, just like in the other ones, we have to do it the same way. We have to have the absolute value, then your symbol, and then a number. But if you look here, we have this 3 and this plus 6 that don't put it in the right format. So we need the absolute value, the symbol, and the number. So what we have to get rid of first is this plus 6. So I'm going to subtract 6 from both sides. So I'm going to 3 times, and I still have inside my absolute value 6 minus 3x. Keep your symbol, and 42 minus 6 is 36. Okay, I still don't have absolute value, symbol, number. I still have this 3 I need to get rid of. And because that says 3 times, the opposite of times is divide. So I'm going to divide both sides by 3. So I have the absolute value of 6 minus 3x is less than 12. Okay, now I have absolute value, symbol, and then a number. So right now I can set up my two cases. So the first one is exactly what we see without the absolute value sign. So I'm going to subtract 6. So I have negative 3x is less than 6. Divide by negative 3. So remember, when you divide by a negative, we have to flip this sign, and we get negative 2. All right, my second case is going to be 6 minus 3x, and then remember, flip the sign, and negative 12, because 12 and negative 12 are equidistant away from 0. So now we're going to subtract 6. So negative 3x is greater than negative 18. We're going to divide by negative 3. So remember, when you divide by a negative, we need to flip that sign, and negative 18 divided by negative 3 is a 6. All right, now let's go graph this. So if we go back to the beginning and just kind of check this out and see if we're doing this correctly or not, I'm going to put my 0 on here. So this is less than, so I kind of have a visual. If that's a less than, that's telling me it's an and problem, and I'm going to shade between two numbers. So let's graph this green one first. I'm at a negative 2. It's an open circle because it's just greater than, so I shade to the right. And now it's any number less than 6. So less than 6 is going to be an open circle, and I shade to the left. And because these two are going at each other, they're crossing, the place that they have in common is between negative 2 and 6, so we shade between. So the only numbers that are going to work are between negative 2 and 6. All right, so actually, is negative 2 an answer? And no, it's not, because we have an open circle here at negative 2. So we go up to negative 2, but don't include it. All right, hope this helps, and good luck on your homework.